Hi guys, you're welcome to my channel. Okay, today we are going to discuss about Star Delta program. We're going to write a simple program, simple PLC program to control Star Delta. Okay, now I have it here now. Let me walk you through the network. This network one is my starting network. Okay, let me put it here. I'm going to be starting network, going to be starting network. Okay, this is for starting to start the operation, right? Then this second network here is my star network to initiate the first command. Once you initiate the first command of the first network, the star contactor, you know the operation of star data already. This one is my main contactor, this one is my star contactor, and this one again is my delta contactor. Okay, then this part here is my signaling lamp to monitor when each of the contactor is in a closed state or which one is in open state. That is this. So this main lamp, star lamp, delta lamp, and fourth lamp. And this is my overload. Okay. This overload here, this overload here is NC to send power to this one to close. Then I have another overload here that is NO. Well, once the other one trip, then this one will close to give me this fourth lamp. So this is how I plan the program. All right. I don't know if I can show you this schematic. Let me show you this. Not this. We are going to talk about this later. Okay. Let's discuss about this. All right. This is the control system for star delta as well. Is a conventional method of controlling an induction motor using star delta. Star delta enables you to start motor with a low speed and you now go to high speed so that the starting current will be reduced. Okay. So that is the purpose of star delta, you know already. So this is the schematic. So this particular schematic, let's simulate just a brief. Let's simulate it briefly. I put it on and now start the system. Once I start the system, these two will close for the first time. After preset time, then this one will take over. Okay, look at it. Look at the arrow. Okay, let me check. Then see the indicator lamp respectively. Let me check if I can change the time to 2 seconds for the purpose of so that it will not take our time. Although, let's go back to the main program anyway. Let's go back to our PLC. Let's see if we can simulate before the time goes off. All right, sorry. So let's simulate the operation of this particular. This is a very simple program. It's a very simple PLC program for Star Delta. So how many networks do I have? I say one here, two, and three. Okay. But I want to monitor the operation from the signaling area, this portion. So let me know when the star take over and start up and when delta take over. Then later we check out we check the whole network. Okay. Okay. Let's see if we can save and download. Sorry. Um, let's save and download. Then put the system on. Let's monitor. Okay. Now let's watch from this portion. This is my main lamp. Main lamp. There is mains contactor lamp, star lamp, delta lamp. So just monitor how both of them take over. Okay. Yeah, the system is running. This is main as closed. Star and mains is running. So this one will take over for a short while. Now this one take over. Okay. So now I will shut down. Then we'll go to the main program where you can visually see them more. Okay. All right. Okay. I just shut down overload. I will show you that too. All right, let's see how this one works. This is the main program. So I put on the system. Yes, mains contactor and start contactor is running. The counter is counting. After preset time, this one will take over. Now it has taken over. Okay. Now, supposing there is a fault and overload coming from friction or resistance coming from mechanical mechanism or moving mechanisms. So in that case, it now give rise to trippage of thermal overload. So this fault lamp will illuminate, and your other overload that is normally closed, this one will trip. So let's do that by activating this particular one. Let's do that by activating two. Look at it, fault lamp has come up. Let's go back to our main program. Look at them, all of them are shutting down. They are all shut down. Now, the major aspect of this particular exercise that made me to make this video is the process of connecting this to PLC. How to make this connection to PLC. And that is the, the, the most challenging aspect of automation programming. You know, you can write a program efficiently, but how do you now carry out the connection? You cannot do that if you don't have the idea of control system. Okay, that is why I always emphasize on this for you to come from control system perspective. In control system, you know how to design, you know how to terminate, you know how to install, you know how to maintain. So when you know the process of the operation sequence of your design, you also know how to write the program and also carry out your termination and your wiring on your PLC. So let's do that now. Let me show you. This is the process. Sorry, oh, sorry. Okay, now look at it. This is my PLC. Let me simulate first before our time go off. Let's simulate. This is the same star delta. This is the wiring connection that we did. I will teach you all this, all right? Let's put on the system. Now, PLC is working. This two is on now. Look at them. Look at these two close. After some time, this one will shut down, this one will take over. Look at it, it has taken over. So this is how to simulate your PLC. Though I also have a little programming I did here using the, let me shut down. Okay, now let me shut down the system. Now, I also have a small little ladder diagram here to at least to illustrate another method of writing delta star delta program. Okay, but the major issue that you need to focus is how to understand the function of this, how to also do your wiring from your PLC, having written your program from your tier portal, and they want to do the connection to your PLC CPU. Okay, so this is the most challenging aspect for some of our trainees face. So you must know how to make this connection and this particular one, you know. And in some cases, you may not even have to do the connection to PLC directly. You may have to also interface a relay between the PLC CPU and your panel. Okay, there are some connection that will require you to feed a relay between this to this to your field device. All right, that's what I mean. So now I just want to show you the process of terminating your PLC wiring. This particular software, let me show you. This particular one now, this one, the termination of this to PLC is what I just showed you in the other control software. How you can do this? Okay, let me identify how many input do we have here. We have start button, we have stop button, we have overload. That's a 3 input only 3 input bit I need. So my output, let's count. 1, 2, 3, 4, 5, 6, including the shutdown fault lamp. That is 7. I have 7 output devices, 7 output bit, and the 3 input bit that I used to write the program. So if I come to my